S price. S price indeed. Price is right. Yep. Hello, everybody. Yeah, there you go. I said hi. Just a quick introduction of who I am. My name is Spencer. I live in New York with my husband and a dog, Eleanor. We live on Roosevelt Island. That was intentional. I'm very introverted. Come say hi. I probably won't say hi to you. Apologize. There is one thing I want to start with, though, is a rapid ice-breaking Q&A. There's a lot of questions you're going to be tempted to ask me. Let's get them out of the way. How tall are you? 6'8". It's really tall. Yeah, I know. Do I play basketball? No, I was a theater kid. Not at all. But I would have been really good. I can assure you that is not true. That is not true. Even if asked sarcastically, please don't. You're welcome to complain about airplanes. Bet you didn't know this. Yeah, my family, yeah, they're tall. So keep these in mind. All right, we got that out of the way. Thank you. I am a engineering manager for a company called Movable Inc., based in New York City. We host the Ember NYC meetup pretty frequently. There's a few of my compatriots here as well. One thing I want to mention about my team is we are currently obsessed with Thinking Aaron's Silly Putty. So if you're interested in learning more about the silly putties that they have available, happy to tell you all about them. They're pretty great. All right. I kid you not. They have a $1,000 silly putty that has real gold in it. It's pretty. We don't have one of those, though. Working on it. Cool. So I'm here to talk to you today about how data visualization can be easy with Ember. I want to start by acknowledging something else that happens, that comes up a lot, which is that data visualization can be hard with D3. And there's a lot of reasons for this, but I think the surface area of D3 is very large, in the same way that Ember is very large. But D3, you end up looking at a lot of the really rich examples that they have available online on how to use the library. And I find it very hard to read. And especially if you're comfortable with Ember's templates, it doesn't really seem to map cleanly. And so one thing that I've found historically is that combining differently opinionated frameworks is a very hard problem to solve. And you end up with a lot of really kind of ugly, messy glue code to get these things to work together. So the thing I want to start with as kind of a way to think about this problem is acknowledge that Ember is already a data visualization framework. This term data down, actions up, the data is already something that is influencing our presentation layer. So we are already taking data and turning it into something visual. So this problem, hopefully, is fairly tractable, given that that's already true. So before we jump into this, because what I want to take you through is how I would go about building a data visualization, is there's actually one data visualization in particular I want to take you guys through how I would build. About 2 years ago, and I think many of you will remember this particular data visualization, there was a night that many of us were watching something, someone already knows, that caused a lot of anxiety. I'm pretty sure I had nightmares about it. Yeah, if you remember. In particular, the little wiggle was the thing that was most difficult to watch. One thing I do want to mention, so for how much anxiety this data visualization created, I do recommend you read the blog post from the authors and designers of this. They have a pretty good explanation for why they chose to add that jitter. You could probably debate whether it was the right choice, but it was a choice that I thought they had a good reason for making. So we're not going to dig too much into that itself, but we're going to talk about how we would build this using Ember, what that might look like. So the way I see it, there are 5 steps, and it kind of depends upon what you're actually building. But for this one, let's say there are 5 steps to building a data visualization with Ember. First thing is about finding our origin. And this is going to help us later on to make sure that the coordinate system we're working within is easy to reason about. Second is to break the visualization down into its component parts. Then we're going to define the scales that we want to work with. I'll talk about what that means. And then obviously this one in particular, animation is a pretty critical part to this visualization. And then as well as accessibility. We want to make sure that we're sensitive to screen readers and other things that may come up with accessibility needs. All right, so we're going to start with finding our origin. So this data visualization, we have just a needle that goes back and forth. And so the thing we should be thinking about is we want this point to be our origin. This is our 0, 0 of our coordinate system. And this is going to help because rotating against 0, 0 is more easy to reason about than doing some sort of translate and rotate that can get really messy very quickly. So to create just this that we have right here with SVG, if we did nothing, SVG by default will set its coordinate system to start on the top left corner. So 0, 0 is the top left. And so if we wanted to draw a circle that was in that point, it would require that we give its x and y center to be 100 pixels each. So if we did not do something to set our origin in a more useful place, then we're going to end up having to remember to always be translating 100 pixels down and 100 pixels to the right. So the first thing we're going to do inside of our SVG is we're just going to create a group and apply a transform to it. And we're just going to translate the coordinate space by 100 pixels in each dimension. So with Ember, we can expand on this a little bit. And let's just make this our outer component. This is basically our SVG. I'm calling it our margin gauge container. Calling this viz a margin gauge, I suppose. And we'll give it a height and width. And with this, we're also going to yield some things that are going to help us later on. Things like what should the radius of the needle be? And also what is the height and width that we're working with. But this gives us something that's a little bit more easy to reason about because 0, 0 is the center of our graph, and that is everything that pivots around it. All right. Next thing, defining our components. So when I look at something like this, I actually see at least 4 distinct components that we can reason about individually. There's the needle. There's the ticks and labels that go around the arc of the graph. There is the border that goes around the whole thing. And then there's those error boundary things, the dark and light shaded red and blues. So let's start with our needle. So this needle, can actually be thought of as 2 fairly simple shapes. One is a triangle, one is a circle. So we're going to draw that shape. And to determine the height of the needle, we're going to make this an input to our component. So we're going to use its radius. We will pass in the radius. And it's this dot radius, not at sign radius, because we will have needed to inverse the radius length since we have to go up 300 pixels. So this would be -1 times the input radius. So we have our needle. The other thing we need to do is we want it to rotate, given the input angle. So what angle is this needle currently at? 0 degrees is vertical, and then we'll go -90 degrees to +90 degrees. So we'll just add a transform around our 2 shapes. So that is the makings of our first component. And so if we actually want to use this inside the context of that container we created earlier, we just stick it in there and give it the container's radius and the current angle of our visualization. So the result is now we have something like this. So I just got a little slider there that's updating the angle, and so we can move it about. I left out, there's obviously some color changing. I left that bit out, but hopefully it's fairly straightforward to implement that. When you're playing with that needle, I hope you've seen this with the DuckTales theme song going with it. It is the greatest, one of the greatest dog gifts that has ever existed. All right. So the next bit, the gauge ticks and labels going around this arc. This is the next component. We want to create a component, and we'll use an each loop to render each one of them. And so similarly, this one we want to think about an input angle for that particular tick. Maybe we'll yield where we actually put the text that goes with the tick. But one thing that's important to kind of note about this one is that there's actually 2 fairly different states based on whether this is in the positive side of the angle or the negative side. And it's based on whether the text is left aligned or right aligned. And so this one gets a little bit trickier. But to start, so if we want to just draw a tick with a label, we'll, in SVG, create a line. We'll create a text, and we'll draw it so that it is at that initial starting position. And in that starting position, because 0 degrees is vertical, as we mentioned before, we actually need to then first rotate it up to 0 degrees, and then that way we have our 0 degrees as our kind of our starting point. So there's a double transform that happens here. That's why there are 2 groups around this tick. And then there's a little bit of code that we have to use to kind of do that extra work to figure out whether the text is left aligned or right aligned and whether it's flipped. I hate code like this, but it kind of is necessary, so I apologize for that. All right, so then putting that all together, again, inside of our margin gauge container, we now have this new component called a margin gauge tick. And similarly, it takes a radius as an input. The size is the length of the actual line or the tick. And then if we want to, we can yield some text. And then it gets positioned really nicely. Cool. All right, next one. This shape. I don't know how to draw geometric shapes using JavaScript. So this is where we can really lean on some open source solutions to help us out. So the first thing we're going to do, please install Ember Auto Import. This is the greatest thing. Thank you, man in the orange. Because you'll notice what I'm not installing right now is Ember D3 shim or whatever it is. So install Ember Auto Import, and then we're just going to install a new dependency, which is D3 shape. D3 has done a really great job of decomposing this fairly monolithic library into separate packages that we can use individually. So D3 shape is all about drawing shapes. How wonderful. So there's a thing we can import from D3 shape, which is the arc tool. So on the right, basic use for this is that you pass in an object where we give it an inner radius, an outer radius, and a start and end angle. Turning this into a component, we'll just call this the arc component. And I just have to acknowledge, by the way, how I think beautiful this looks with angle bracket components. It's very readable, looks just like SVG would. And so we're going to give it an inner radius and outer radius, and then start and end angles. And now we've got our happy border. All right, the gauge error boundaries. So this one starts to get a little trickier because now we have to do some data manipulation. We don't really have a way of just taking a single value as an input and working with it. So this one, sometimes it's difficult to think about or reason about these things when we're like looking at an arc and angles. And so I think it's useful to start just flattening this out and thinking about this on just a flat one-dimensional whatever you call that. So let's imagine kind of the base case where the needle's at 0. And in this case, we have 3 error ranges, which is to say that we can be plus or minus 15 for the first range, plus or minus 25 degrees for the second range, or plus or minus 30 degrees for the third range. So what we are going to want to do is take these 2 inputs and then generate an array of what we'll call wedges. And we can just use that same arc component we made before, where we already have the inner radius and outer radius, but we're just going to create a wedge that has a start and end angle. So similarly, if we have a slightly not standard case, which is where the current angle is 10 degrees, and we have kind of this funky positioning that we have, but we're going to do the same thing. And we're going to take the angle in those error ranges and convert that into an array of wedges. So now that we have that array of wedges, just for each wedge, draw an arc. And then if we actually dump that into our margin gauge container again, using the radius we already determined and inner radius, which is 60% of the outer radius, we get something that looks like this. So we're getting there. We're getting there. The pieces are coming together. All right, next thing, defining a scale. So what I mean by this is in our viz that we have here, what we are seeing is a positive and negative margin in terms of percent. But what we want to consume is something that's in terms of angles. So if we have a margin of -5, that should roughly map to -37.5 degrees. If you guys remember like algebra, high school, this is where that would really come in handy. Or, of course, our handy dandy D3 library. So D3 has another package called D3 Scale, which provides a whole suite of different types of scales that you can use for visualizations like this. This one is going to end up being a linear scale because it maps linearly, y = mx plus b, essentially. And so we're going to import scale linear. You will probably type linear scale and get it wrong. I do that every time. And then we're going to turn that, we'll create an instance of a linear scale. We're going to give it an input range of -12 margin to +12 margin. And we want to map that to the output range of -90 degrees to +90 degrees. So the result for something like this is that we give an input a margin of 0, we get 0 degrees. Input a margin of -12, we get -90 degrees. Or similarly, a margin of 6, and we get 45 degrees. So using this inside of our component, the easiest way to do this would be to just pop that scale onto a property called scale. It returns a function. So this is just a function being assigned to the scale property. And then we'll create a computed property that uses the margin as its input, and then it's going to output the angle. It's a great place to use computed properties. All right, animation. So there's a couple animations happening here. One we actually don't get to see in this little short clip that we have, which is that if the margin changes meaningfully, it has to animate to its new position. And the other animation, of course, is that very harassing wiggle. So again, this is a place where D3 has some tools that can really help us. D3 Ease, which helps us create those sort of silky smooth feeling animations that can ease in and ease out. They have a really, really rich library of different easing functions you can use. And then D3 Interpolate is actually similar to D3 Scale in some ways, but it helps you find, given that you're 50% through your animation, here's what the value should be at this point in time. I wished I had a really good story for you here, but I'm going to do a little hand waving because I don't think I have a great story when it comes to animation for this just yet. So I'm going to throw up a slide. There's a question mark. So Ember Animated is a really, really promising tool that I would love to figure out how to make it work with this. I couldn't at this point. There's also something I've explored with Ember Concurrency. I also wonder if there are probably some other open source libraries out there that might fit this use case. But what I'm going to describe is kind of what I would love to have, though this is ripe with pitfalls, is something similar to how Ember Animated allows you to animate things. But we're going to be animating values rather than attributes on DOM nodes. And what I'd love to be able to do is take D3's easing and interpolation methods, create an animation, and then yield in a generator function each frame of that animation. How that would look in a template might be something like this, where we have an animate value component. Again, this is very similar conceptually to Ember Animated, though very different functionally. So this way, we just intercept the angle as it changes and yield the animated value of the angle to our component inside. So the result of that is something like this. So if I click, it's going to animate to its new position. And we can do that and have a lot of fun. I don't have an animated GIF to go with that one. But the next part of this is the wiggle. And this is why I think generator functions are a really, really great tool for animation. Is now that we have yielded that initial animation to go from the start point to the end point, and we've completed all of those frames, now we want to just animate forever and add a little bit of noise to our animation. So that blog post I referenced earlier where they showed that little wiggle, they did talk about, it's called the Perlin noise algorithm. Being someone who has a degree in film production, I have no idea what this is, but there are some code examples which I lovingly borrowed. So this code here is essentially saying that forever, we're just going to periodically add some values to our result place. So the result is then that we have this little wiggle. So when we move to a new place, it's going to wiggle. Move to another place, it wiggles a little bit more. Okay, so putting this all together so far, we have our outer container, which is our SVG, which translates the coordinate system. We have a way of animating the angle and yielding that to our components so they can all respond to that animation. We have our margin gauge error component, our border. We have each of the ticks that we want to render on there. And then we have the needle, of course. So the result is something that looks like this. Cool. Woo! Yeah. Thank you. Of course, there's one last thing and very important thing that I wanted to add to this, which is accessibility. And there's obviously a lot of accessibility concerns with data visualization, but one that is really unique to data visualization is how they work with screen readers. And so the thing I would love to just at least distinguish with this visualization is finding a way to add a label to your data visualization so that it says something meaningful. You could do something literal, which is like a blue needle at an 85-degree angle. If the screen reader reads this, this isn't going to mean much. It's describing objectively what you see, but it's not describing what it means. So you might instead try to generate some text that looks more like this. Our forecast gives the Democrat a 1.2% lead on average with about a 75% certainty. The final result will fall between this and that. That is going to mean a lot more to the person using a screen reader. And so we can do this. This is another great place where angle bracket components are wonderful because now we can just add attributes, and we can add our accessibility attributes without setting up attribute bindings. I was hoping to actually use the DESC desk tag inside of the SVG, which is how you would normally give it a description. I could not get it to work with ARIA Live. And ARIA Live is something that will announce when things change. So in this case, I've actually given it a description that is outside of the SVG. And so every time now, if there is a change and the user is not necessarily focused in that area, it will announce to them what the new visualization is now showing to them. So in a moment, you'll see I will click on this little slider. I'm doing this live, too. There you go. You can see now it updated and it's reading off a more meaningful description as it changed. All right. So again, to recap here, the 5 steps of building a visualization with Ember, as I see it. Find our origin, define the components, break them down, define your scales, and then adding in animation and accessibility. So hopefully, you'll get a sense that this is something that I don't think is necessarily easy because data visualizations can get very complex. They can get very mathy. But I think at least initially this is a tractable problem that is easy to start with. So I hope that's true. That's all I got. Thank you.